Okay, today we get to talk about complex numbers. So we're going to talk about imaginary numbers, or what's called complex numbers, and we're going to explain what they are and how to do operations using complex numbers. So again, it's pretty straightforward once you understand what a complex number is. And we're going to introduce I, and I again is a imaginary number. It's a specific imaginary number, and we're going to define it. And once we define it, you'll see how this can be used easily. Okay, so here's what we're going to cover in this section. So in all of these, okay, so here's the chapter outline again. So we're going to skip to section 1.4. So this video is going to be 1.4, and so we're going to skip to that. So here's the learning objectives for this section. And so these are the things we're going to cover today. Okay, and again, the thing about this book and these chapters is it's all about examples. So I'm going to try to explain as I go through these examples. Okay, so again, make sure you're able to do these on your own. Okay, and don't just listen to me and watch the videos, but make sure you're able to do these problems on your own without looking at the solutions. So once you go through these, go through them again and see if you can work out these examples here. Okay, so here's the definitions that I want to go cover with you. So here's the idea. Imaginary numbers are those of the form where you have a negative number under a radical, a square root. Okay, those are imaginary numbers. Okay, where k in this case is a positive real number. So you're taking the square root of a negative real number. That is an imaginary number. Okay. Now there's a unit in the imaginary numbers, the unit I. I is a specific value. Okay. And we define it as the square root of -1. So anytime you have or see the square root of -1, we call that I. Okay, so right over here, this is I. So if we take I squared, well, that's going to be the square root of -1 times the square root of -1. And so that becomes the square root of -1 squared, which then cancels out each other, and you end up with a -1. So I squared is -1. Okay? So this is the basic stuff you need to realize and remember. Okay? So again, rewriting imaginary numbers, we can always rewrite an imaginary number. If we look at any positive number k, we can write this as the square root of -k, but then what we can do is we can use the properties of square roots, and we can write this under here. So listen carefully. You can rewrite this as -1 times k, right? And so you can write this as the square root of the quantity -1 times k. And then what you could do is you could split it into two radicals, right? You can write that as the product of two radicals. And so you can write that as the product of the square root of -1 times the square root of k. And then what happens is, well, we know by here the definition of the square root of -1 is I, so you can replace that with I, and then you just have this. And so this is where the equality comes in. So you can rewrite any imaginary number in this form. Okay, so remember these. Okay, this is going to be important. This is what's going to make this easier to do. Okay, if you remember these. So here's an example. So this is just practice writing numbers in imaginary forms with I. Okay, so here we have the square root of -7. So we want to split this up into the square root of -1 times 7. And then you can split that up into two square roots so that it's the product of two square roots. And then you'll have the square root of -1 times the square root of 7. And so then the square root of -1 becomes I. And so I always goes in front. And so it'll be I times the square root of 7. Okay, and that's what we get here. Okay, and then likewise, this will become I times the square root of 81, which then the square root of 81 is 9, so you write it as 9i. And in this case, the 9 goes in front. Okay, so typically when we write these, if we have I, we write I in front But then if we're able to take the square root of a number, then we put the number in front of the I. Okay, so square roots go after the I. Typically, whole numbers or real numbers go in front of the I. Okay, so that's just by construct. Okay, and then C, here we have negative 24, and so we're going to split this up into negative 1, the square root of negative 1, times the square root of 24. And so we get I times the square root of 24, and then we can split this up into 4 times 6. Well, now we can split this up into the square root of 4 times the square root of 6, and of course the square root of 4 is 2, so the 2 goes in front, so we get 2I times the square root of 6. And then finally, for part D, we've got this. Now we've got a negative 3 out here. We can ignore that for the moment. What we want to concentrate on is this negative 16. So 16 is a perfect square. So we can rewrite this as negative 1 times 16 under the radical. And then we can use the property of roots, and we can write this as the square root of negative 1 times the square root of 16. And then the square root of negative 1 becomes I. And then we get the square root of 16, which is 4. And that's where this 4 comes in. Now we can multiply the negative 3 and the 4, and we get negative 12. And so our final answer is negative 12I. And so again, practice these. Do them on your own. Make up your own. Do some out of the book. There's plenty of examples and exercises at the end of the book that you can use just for practice. In addition to, we're going to get lots of practice in class with this stuff. So now let's look at this. Now here we have x is equal to negative 6 plus the square root of negative 16 divided by 2. And so we want to simplify this too. And then we've got this other one that says x is equal to the same thing, but it's plus. Okay, so these are plus and negative. So these are very similar, except one has a plus and one has a negative. Now these are not real numbers, right? You got to understand that these are not real numbers because you've got a negative under the radical. Okay, so these are not real, but we know that these are solutions to the polynomial, the quadratic here, right? Now this quadratic, if you notice, is not factorable. Okay, this is not a factorable polynomial the way as far as with real roots. Okay, the way we normally factor things. Okay. Now, what we want to do is we want to simplify this expression here. So what we're going to do is we're going to basically just take what we did in the last example, and we're going to apply it in this situation, see what we can simplify this to. So what we do is we have to use I. And so what we're going to use is we're going to basically just do the same thing. We're going to focus on this first, simplify this, and then see what we can do. So again, this is negative 16 under here, so we're going to do the same thing that we did before, and we're going to write this as negative square root of 1 times, the square root of negative 1 times the square root of 16. And so we're going to get that I, because the square root of negative 1 is I. By definition, we're going to get I times the square root of 16. And so we get negative 6 plus this divided by 2. And now what we're going to do is, what we're going to do is we know this is 4. And so we're going to get 4I. And now what we can do is we got a common denominator here, so we can factor out a 2. And so if we factor out a 2 here, we can cancel the 2 with this 2, because 2 divided by 2 is 1. And so we're going to get negative 3 plus 2I as our final answer. And so we can't factor this or simplify this any further. Now, if we take this and we plug it in for x here and here, then what we're going to end up doing is we'll end up getting 0. It'll solve. Okay, so if we plug this in for x, we'll get a true statement. Now, let's look at this example here. So we're going to write complex numbers in standard form. What is standard form? Well, guess what? This is standard form. Anything that has the form of a plus bi is standard form. So there's a real part and an imaginary part. We call this the imaginary part of the complex number and the real part of the complex number. So it's always a plus some multiple of I. So it's going to be a plus b times I, a plus bi. Okay, so this is standard form. Okay, so we're going to take all three of these or four of these parts, and we're going to write it in the form of a plus bi. So part A, what we're going to do is we're going to solve for this. So we know that 49 is a square. This will become the square root of -1 times 49. And we know that this is a perfect square, so that's going to be 7 squared, right? And so 7 squared cancels with the square root, okay? And so what this will become is I times 7, or 7i, okay? So this will become 2 plus 7i. And then a will be 2, and then the b will be 7, okay? And so we got our a and b here, so this is how we did it. And then likewise for this one here, you do the same thing. This one's going to be a little bit more complicated because this is not a perfect square, but we can factor this into two numbers. We can split this up into two factors that one is a perfect square because it's 4 times 3. And so we can do this. So the -12 will become 0. Why? Because we need an a, right? It has to be in this form. There's no real part, right? This is the imaginary part of the number. So over here, if you look, this is the real part. This is the imaginary part. Here, there's no real part, so we would put 0 in, right? 0. And so this would be I times the square root of 7, or excuse me, I'm sorry, square root of 12. And then we can split this up into 4 times 3. And then the square root of 4 is 2, and there's where the 2 comes. And then we're left over with the square root of 3, which we can't do anything more with. So our final answer is going to be this. 0 plus 2i times the square root of 3. Now the real part is going to be 2 times the square root of 3. That's going to be the b, right? This is going to be our b part. Okay, the real part is 0. The imaginary part of the complex numbers is this whole thing. But b is going to be 2 times the square root of 3. Okay, so it's everything that's without the I. And then finally here, we're going to again concentrate on this and see if we can simplify this thing and put it in this form. So what we're going to do is we're going to simplify the numerator here, and then what we're going to do is write it and split it up into two fractions if necessary, and then we'll know what our a and b are immediately. Okay, so again, you notice that this is a perfect square. This is 5 squared. We can rewrite this as 5 squared. So we can write this as the square root of -1 times 5 squared. And then we can split it up into the product of two radicals. We can write this as the square root of -1 times the square root of 5 squared. And then, of course, 5 squared, the square root of 5 squared is 5. And so we get the square root of -1, which is I, and we get 5. So this becomes 3 times 5i, or 15i, if you will. Okay, and this is 4. Okay, plus that. Okay, so if we, and then we'll have the 20. So we'll see what happens here. So here, we have this. Oops. So we got this right here. And then we're going to simplify it by breaking it into two fractions. And then 4 divided by 20 gives us 1/5. And then the 15 divided by 20 gives us 3/4. And so now our a is 1/5 and our b is 3/4. Now what about c here? Well, I skipped c. Now c here is a real number, right? So in this case, there is no imaginary part. There's just the real part. So the imaginary part will be 0i. Okay, so we can rewrite 7 as 7 plus 0 times I. And so in this case, a would be 7 and b would be 0. Okay, so pretty straightforward. Okay, so now let's think about our sets of numbers. Okay, so in our sets, and it's very important to understand how sets of numbers are related to each other. Okay, so it says here, look at this. So think about this here, the complex numbers of the form a plus bi, where a and b are real numbers, and I is the square root of -1, includes everything. Complex numbers are like the biggest numbers you can have. Okay, it's the largest set of numbers. Okay, now if we break that into two pieces, we have real numbers, okay, which are all of these, and then we have imaginary numbers. So imaginary numbers are outside real numbers. They're what we call disjoint sets. Okay, so they don't overlap in any way. But together, if we take what we call the union of those two sets, so we basically put all of them together in one big pile, then we get the complex numbers. And all complex numbers compose of a real number and an imaginary number. And so again, the reason why is because we could take all real numbers, right? Any real number and write it as 0i, right? So any real number can be written as a complex number. So in other words, all real numbers are complex, but not all complex numbers are real, okay? So now, inside the real numbers, we've got all kinds of sets. So it starts with our where are they? Oh, natural numbers, right? So here are the counting numbers, or what we call the natural numbers, right? 1, 2, 3, and so on. And then if we include 0 in this set, we get whole numbers. So whole numbers are the natural numbers plus 0. And then if we include all of the negative values of the natural numbers and include those, then we get the integers, okay, which is actually represented by the letter Z, okay. And then if we expand it even further and we include fractions, right? So the integers are just there's no fractions here, right? They all numbers are going to be written as a whole number, right? Right, as a digit, okay. But as soon as we include fractions and any whole number, any integer can be written as a fraction because we can write these as over 1, right? So we can rewrite these as fractions. So again, but not all fractions can be written as whole numbers. So that's why it's a bigger set. So integers is included in the set of rational numbers. Okay. Whole numbers is included in the set of integers. Natural numbers is included inside the set of whole numbers. And so there are subsets of each other. Okay. Now, what about irrational? Irrational numbers are completely a different set. Irrational numbers do not overlap with the rest of these. So these are two separate sets, but they're all included in real numbers. Okay, so rational numbers are numbers that can be written as a fraction, right? So in other words, we can write them as either a repeating decimal or a terminating decimal. Okay, that's another way of saying it. Irrational numbers are numbers that cannot be written as a fraction. For example, pi, the square root of 2, the number e, those are all irrational numbers. Okay, so again, just this is a little bit of review, but make sure you understand this. So now let's talk about adding and subtracting complex numbers. So if I have these two numbers here, right? So I've got these two groups of numbers, these two complex numbers here, and I want to add them, or if I want to take these two and subtract them. You apply the same principles that we do for real numbers when we're dealing with variables, right? So if instead of I, let's say we had an x here instead of I, okay, right? X is just a variable that represents a number. Well, that's exactly what I is. I is a specific variable, and it represents a specific number. Okay, so it's not really a number. It's like E. right? E represents a specific number. I represents a specific number. But it might be helpful to think of it as like a variable for the moment, because when you add these and you treat I like as if it was like an X, then what do? Well, we add like terms. So in this case, we're going to add all of the terms that have I in them together, and then we're going to add all of the numbers that have just real numbers. So here's how it works. We're going to add the real parts together and add the imaginary parts together, right? So we take the imaginary parts, group them together. We take the real parts and group them together, and then we simplify. And same way with subtraction. The only thing you have to watch out is you have to distribute this negative sign across this sign here. So when you distribute the negative, this will become positive, and this will become a plus sign. Okay, so again, one way you could think of it is change this to a plus negative, and or think about you're multiplying by -1 here. So if you change this to a plus -1 times this, that might help. Okay, so in this case here, what we're going to do is we can drop the parentheses because it's a plus sign. And so remember, the negative goes with the 5. And so what we're going to do is we're going to use the commutative law. We're going to move numbers around, and we're going to group the imaginary parts, and we're going to group the real parts and simplify. And so for part A, we drop the parentheses, right? And so again, we want to make sure that the negative sign stays with the 5. And so to make sure that we don't forget that, you can put parentheses around it. And then what we're going to do is we're going to group this -5 with the 2. So we get 2 plus -5. And then we're going to take the 3i and the 2i and put those together, right? So we're going to move things around. And then what we're going to do is bracket them and simplify. So 2 plus a -5 is -3. 3 i's plus 2 i's equals 5 i's. So we end up with this, and we know that a is -3, so the real part is -3. And then we have a coefficient of 5, so b is 5 on the imaginary part, and that's it. Okay, so the only thing we have to do differently over here, is, since it's subtraction, is we're going to make this a plus. So we're going to make this a plus 2, and then we're going to make this a plus I times the square root of 2. And so if we do that, we get this. And then again, we're going to do the same thing. We're going to move things around and group things by real and imaginary parts. So we get the -5 plus 2 together, and then we get the plus -4i, right? Because again, the negative goes with the 4, so it's helpful to write this as a plus negative. And then the negative part goes with the 4i. And so these two get added, and then this gets added with this, and of course, we factor out the I and then put everything together. Okay, so here this is going to become a -3, and when we factor out the I here, we get what? We get this part here. We get -4 plus the square root of I. And so what happens is A is -3, but our B is going to be this whole thing, -4 plus the square root of 2. Now here we're going to multiply complex numbers. So here we're going to multiply each one of these. So we'll start with A. And now here's the thing. What we're going to do is we're going to use the root principle backwards. So remember when I said that you could take the product of, you could take a radical and you can put them together. Okay, you could do that here. Okay, but we're going to do something a little bit differently. Okay, so notice that what we're going to do is, notice that this is a -4 and this is -9. So what we're going to do is we're going to put I in here. So the easiest way to do this is we're going to make this into what? -1 times 4, and this will be -1 times 9. And then we could split this up into two radicals for this one, two radicals for this one. And what we're going to get is the square root of -1 times the square root of 4 times the square root of -1 times the square root of 9. Well, the square root of 4 is 2, and the square root of 9 is 3. And so we're going to get two square roots of 1s in there. Well, what are we going to do with that? Well, remember when we talked about at the very beginning about this I squared? Well, that's what we're going to end up getting. Okay, so here's what we have, right? So this is what we have from what I just said, and we're going to put them together, and we get 6I squared. Well, what happens to I squared? Well, that's the square root of 1 times the square root of 1, and we can put those two square roots together, and we get the square root of -1 times -1, which is a positive 1. And so then we get the square root of 1, which is, or excuse me, hold on. Oh, I'm sorry. This is going to be the square root of -1 times the square root of -1, like I said. But if you take the square root of -1 and you multiply this by the square root of -1, well, you get the square root of -1 squared. And then what happens is, what do you get out of that? Well, the square root is undone by squaring it, and you get -1 out. And so that's where the -1 comes in. And then you multiply that by 6. And then what happens here is now, this we get -6, but that's the real part. So in that case, we get 0i. And again, why are we doing that? Because the directions tell us to write it in this form. So we have to add a 0i, even though there's no imaginary part. There is if we write 0i. So this is -6 plus 0i. Oops. Now what about b? Here we got the square root of -6 and then this thing. Well, in this case here, we're going to distribute. Okay. We could do it either, we could do this separately or distribute first or distribute later. It's totally up to you. Okay. So, in other words, this we can write as what? The square root of 6i, or I times the square root of 6. And then we can distribute with the 2, and then distribute with the square root of -3. Okay, so that's what they did. So here we go. So here we got this here. We pulled out the I, right? So we become I times the square root of 3, and this becomes I times the square root of 6, and then we're going to distribute, use the distributive property here. And what we're going to get is, when we distribute, we're going to get 2i, right? So we get 2i times the square root of 6. And then this is going to be what? I times I is I squared, square root of 6 times the square root of 3. Well, then we could pull the 6 and the 3 under the radical, and 3 times 6 is 18, and so we get the square root of 18. Now that we have this, now we can do something with this, because this is 2 times 9, where 9 is a perfect square. And we know this, by definition of I, is going to be -1. So what happens is, this stays the same. There's nothing we can do with this at this point. It's going to be 2i square root of 6 plus -1 times 3. Right? Because the square root of 9 is 3. So we get -3 times the square root of 2. And so now we get 2i times the square root of 6 minus 3 times the square root of I, or excuse me, square root of 2. And so now at this point here, what are we going to do with this? Well, here we can simplify this, if you look, because we can rewrite this, right? Because we wanted an a plus bi. So here's the I part, so we want that on the other side. So we can flip this around. So we're going to write this as a plus negative. So the negative sign goes with this, plus 2i minus 6. And so now we know what a and b are. Our a is this, and our b is the 2 times the square root of 6. Oops, sorry. And then, of course, with c, we're going to do the FOIL method. So we've got I and I, so we got this here. So we're going to use the FOIL method here. So the first thing we're going to do is 6 times 4 is 24. And then we're going to do 6 times I, which is 6i. And then we're going to do minus 5i times 4, which is going to be a minus 20i. So minus 20i. Then we got a minus 5i, which is going to give us, times I, which is going to give us a minus 5 times I squared, which is going to be -1. So we get minus 5 times -1. And so now if we simplify this, what do we get? We get 24 plus 6i minus 20i plus 5. And then if we rearrange and add, well, this gives us negative 14, and these two add up to 29, and so we write the real part first, 29. In this case, we get negative 14 or minus 14, so it's going to be minus 14i. And so A is 29, B is negative 14. Okay, because remember, plus. It's always in with a plus. So B is negative 14 in this case. Okay, now, what about D? Same thing. Here, though, look at this. We've got a form. This is 2 plus bi, or excuse me, this is 2 plus 3i, 2 minus 3i. This is of the form a plus b times a minus b, which is a special form. So this is going to give us a difference of two squares. So this is your a, and this is your b. So it's going to be a squared minus b squared. Well, what's a squared? It's going to be 4. What's b squared? It's going to be 9i squared, which is negative 9. And so what we're going to get is we're going to get 4 minus this, which then gives us what? Plus 9. So 4 plus 9 is 13. So that's real. So then our imaginary part is going to be 0i. Okay? Okay, now, what about checking a complex root by substitution? So what do we mean by a complex root? It's a root. So remember, a root is any value of x that makes an equation, let's say a quadratic equation, equal to 0. Okay, or graphically, it's where the line or the graph of the equation, the graph of the function, crosses or intersects with the x-axis. Okay, so those are what we call roots, or the zeros of the equation. So now it says verify that x equal to this is a solution. In other words, if we plug in negative 3 plus 2i into this part of the equation, we will get 0. If it does, then it's a solution. So what we're going to do is we're going to substitute in this wherever there's an x. Okay, so that means we're going to have the quantity negative 3 plus 2i squared plus 6 times the quantity negative 3 plus 2i. And then we're going to add 13, and we're going to simplify and see if we get 0. So if you do that, here's what it looks like. Okay, so here we're going to just substitute, right? So here's our substitution I just said. We're going to substitute in for x here and here. And now what we're going to do is we're going to simplify this. So we have to expand this out. So we're going to use the distribution method or FOIL method. So we're going to get negative 3 squared plus negative 2 times negative 3, right? So we got negative 3 times this, and then we got 2 times negative 3 again. So we're going to do this twice. So we got 2 times this, and then we got this squared. Okay, so this is the FOIL method. Okay, and then what we're going to do is we're going to, then distribute the 6 here across this here, the plus, and so we get 6 times negative 3, which is going to give us negative 18, and we get 6 times 2, which is 12, and plus, with the I, so it's going to be 12i, and then we have the 12, the plus 13. Now, if we simplify this, this is going to give us 9. There's our 9. This is going to simplify to what? It's going to be negative 12, right? There's our minus 12i. And this is going to equal what? 4, because it's going to be 2 squared times I squared, because the power rule, or excuse me, the properties of exponents here says that we can distribute the square across these two products, okay? These two factors. So this is going to be 2 squared times I squared, which is going to be 4 times I squared. Well, I squared is negative 1, so it's going to be negative 4. So it's going to be this, okay? So 4i squared, there's where that comes from. So we get 9 minus 12i plus 4i squared plus 12i minus 5. Now, the 12i and the negative 12i, look at that, they're opposite signs, so they cancel out. This is going to go away. Okay? So now we get 9 what? Plus this, which is negative 4, minus 5. So we're going to get 9 minus 4 minus 5, which is 9 minus 9, which gives you 0. And therefore, it's a solution because we got a true statement. Okay. Again, I hope that makes sense. So here we go. Here's another one. So now we're going to see if this is a root. Now it's slightly different form. So it's not equal to 0, but we can easily make this equal to 0. But in any case, we don't have to because we got this negative 7. So what we can do is we can plug in this value here for x, here and here, and then simplify this side and see if we get negative 7. So if we get negative 7 is equal to negative 7, we're done. So we don't have to necessarily move this over to get started. Okay, so let's do that. So here's what we're going to do. We're going to plug in. Again, we're going to take this value here of x, plug it into here, and plug it into here. And now we're going to simplify. So we're going to get 4 minus 2 times, right? Minus 2 times this times this, which is going to give us 4. Okay, as we get 2 times this times this, it's going to give us 2 times the square root of 3. And we're going to do that twice, which gives us 4. Okay, so 4i times the square root of 3. Okay, so do you see that? So there's that. And then here, we're going to square this, and we get I squared times this squared, which is 3. We get this whole thing. Remember, distribute the power to the I and to this. So we get I squared, and then we get this squared, which the square root of 3 squared is going to be 3. And so we get 3i squared, which is going to be negative 1 times 3, which is negative 3. So that's where we get this minus 3 here for. So we get 4 minus 4i times the square root of 3 minus 3 minus 8, right? And then plus 4i times the square root of 3. Now notice here, look at this. This cancels with this. They're the same but opposite signs. So this goes away. And what do we end up with? We end up with 4 minus 3, which is 1, minus 8, which is negative 7. And we get negative 7 is equal to negative 7, which is always true. Okay, now here's another one. Now I'm going to explain to you how to look at these. Okay, so now remember what I means. So I is the square root of negative 1. Okay, so I squared is negative 1. But what if I say I to the third? Well, if I know I squared is negative 1, and I multiply that by I, then I get negative 1 times I. So I get negative I. So in other words, if we want to simplify this, I to the first is I, which is square root of negative 1. I squared is equal to negative 1. Well, and then if I do I cubed, well, that's just negative 1 times I, right? Or negative I. Now, if I do it again, well, now it's I to the fourth, but what can I do? I can write that as I squared times I squared, right? Using the properties of exponents. And if I know that I squared is negative 1, then I can then rewrite it as negative 1 times negative 1, which is positive 1. So that tells me that I to the fourth is 1. Now, what happens if I go one more and say I to the fifth? Well, if I to the fourth, as we just showed, is 1, well, then what's I to the fifth? Well, it's just 1 times I, which is I. So what happens is as I go full circle. So I to the first is I to the I squared is negative 1. I to the third power is negative I, and then I to the fourth power is positive 1. And then it starts over. So for every multiple of 4, it starts over. Okay, or if you want to start at I to the 0, which is 1, right? You can start there. And so what we could do is we could start using this and see about um, dividing, right? We could look at the exponent, whatever the exponent is, and we could say, okay, if I know that every fourth one it repeats, right? So what happens if it's divisible by 4? If the exponent is divisible by 4, which means it has a remainder of 0, then the value is going to be 1, positive 1. What if it's not divisible by 4, but has a remainder of 1? Well, in that case, it's going to be the same as I to the first. And so the answer will be just I. If it's not divisible by 4 but has a remainder of 2, then you're going to have what? It's going to be like I squared, which is going to be negative 1. And then if it has a remainder of 3 when you divide the exponent by 4, then it's going to be equal to negative I. And then it repeats itself. So this gives us a way to decide very quickly what the values of these 4 parts are going to be. Because all we have to do is take, for example, the first one and say, okay, let's divide this and see how many multiples of 4 we can get out. Because any multiple of 4 is going to give us 1. Right? So because I to the fourth, as we saw, is positive 1. Okay? So now, if I divide this by 4, is this divisible by 4? No. Okay, so how many 4s go into this? Well, it goes all the way up to 20. Okay, so what's that? I can divide this by 4, and I'll get 4 times 5, which is 20, but then I'll get a remainder of 2. Well, now, what's I squared? Well, I squared is negative 1, which means this whole thing is going to be negative 1. Okay, what about this one here? I to the 28th. Well, again, ask ourselves, is this divisible by 4? And in this case, it is, because 4 times 7 is 28. So that means the remainder is going to be 0, and I to the 0 is 1. So this is going to be 1, because any multiple of 4 is going to be 1. Okay? And then I to the 57th, well, we look at what's the largest, how many 4s, what's the remainder here? So 4 goes into this 14 times, and we're going to have a remainder of 1. So that means that this reduces to I. So far we've got, this is going to be negative 1. This reduces to 1. And this reduces to what? I. Now what about this one? This one here, well, how many 4s go into this? Well, this is going to go into what? How many times? It's going to be, oops, hold on. So it goes into 7 once. So that's going to leave a remainder of 3, 35. So what is this? So how many times does 4 go into 35? Well, it's going to be 8. So it goes into 18 times. And so what are we going to end up having? A remainder of 3. Because it goes 32, and then we're going to have a remainder of 3 here. So again, that means I to the 3, which means it's going to be what? Negative I. So this is going to reduce to negative I. Okay. And so again, look at the results here. Here's the idea. So 22 divided by 4 is 5 with a remainder of 2. That's the key here. Because then we know that any power of I that's 4 is going to be equal 1. So 1 to any power is 1. So this is just always going to be 1. This is going to be negative 1. So of course this is going to end up being negative 1 like we said. And then furthermore, we have this one. So we're going to do the same thing. 28 divided by 4 is 7 with a remainder of 0, which means we're going to have a remainder of 1. And so again, just like with C and D, it's all about the pattern, right? The pattern is going to easily tell us which one of those we're going to have, because it can only be one of those 4 outcomes when we're talking about powers of I. It's either going to be I, negative I, or excuse me, I'm sorry, I, negative 1, well, yeah, never mind, I misspoke. You could have negative I. So it's either going to be I, -1, negative I, +1. Okay, it's only going to be one of those four when you're dealing with powers of I. Okay, dividing complex numbers. Let's talk about that. So now we want to do is we want to divide these and put them into the standard form for a complex number. Okay, so how are we going to do this? Okay, so let's take a look at the first one. Okay, well, the thing here is we have an I in the denominator. Oh boy, we cannot have I in the denominator here. So what we're going to do is we're going to end up multiplying the top and the bottom by what we call the conjugate. Okay, because we want to get rid of I in the denominator. So we're going to multiply the top and the bottom by what we call the conjugate of the bottom. The conjugate is the same form except it has a plus sign. So the conjugate of 5 minus I is 5 plus I. And so we're going to multiply the top and the bottom by that conjugate. And what's going to happen is things are going to simplify very nicely in the bottom, and then we'll be able to simplify this whole expression and put it in this form. Okay? So that's what we did. So here we're going to multiply the top and the bottom by the conjugate of 5 minus I. And look at this. The i's are going to disappear because when we do this, we get the difference of two squares. Okay? We get 5 squared minus I squared. But I squared, remember, is -1. So we get minus a -1, which is the same as plus 1. Okay, so we get 5 squared plus 1, which is 26. And then what we do is now we multiply these two and we get this, which then reduces to what? 10 plus 2i. Now we can split this up into two fractions with a common denominator, and we write this as 10 divided by 26. So here's our real part, and then here's our imaginary part. And then now we can simplify this down to 5/13 plus 1/13 I. And so this is the best we can do. So this is the final answer. And then now we're going to do the same thing here, except now we've got this on the numerator. So here we had a constant. Now we're going to make it a little bit more complicated by putting an I up here and see what we get. But we're still going to have to get the I out of the denominator. Okay, still have to do that. So we're going to multiply by the conjugate again. Okay, so but the conjugate in this case is minus, right? So we're going to multiply the top and bottom by 2 minus I, and that'll get rid of the I because here we're going to get the difference of two squares, which is going to get rid of the I. Okay, so we're going to get 2 squared plus 1 squared. Why is it plus? Because we get the 2 squared minus I squared, which is -1. So it's going to be minus a negative, which is plus. So we get this plus again. So we're going to get 5 here. Okay, so now what happens here? We're going to simplify this. We get, by using the distributive properties, we're going to distribute the 3 to the 2 and to the -I. So we get 6 minus 3i. And then we're going to distribute the I to both, which we're going to get -2i and plus I squared. And that's these two. And now we're going to simplify. These are going to be added because these are like terms, right? They both have I. So this is going to be minus 5i. And this is going to be minus what? Minus 1, because this is -1. So it's going to be a minus 1. And what's going to happen is we're going to get this now. Okay, so now we get 6 minus 5i minus 1. And then, of course, this is going to make this into a 5. Okay, so we're going to get 5 minus 5i divided by 5. And now we can factor out a 5 and cancel with the 5 at the bottom. So we don't have to do it necessarily this way. We could have just factored out 5 here, canceled the 5, and we get 1 minus I. But they did it this way. It's fine. It's 6 half a dozen of the other. So in this case here, we get the same thing, right? 5 divided by 5 is 1, and then -5i over 5 is 1i, which is I. So we get the same thing. Now C. Now here we're going to do it a little differently. Now we're going to rewrite this as terms of I. So we get one more step. All we have to do is rewrite this in terms of I. Okay, now look what happens here. Now this is a perfect square and this is a perfect square, so this is going to be 6i and this is going to be 3i, and now we've got it into the form that we had in part B. So basically, if we have it in this case, we want to simplify it to this, and then we can do the same thing that we did in part B. So everything in part B follows from here. So we're going to multiply the top and the bottom by the conjugate of the bottom, which is going to be 3 minus 3i. Or actually, you know what I see here? We can factor out a 3 on the top. So we can factor out a 3 here and a 3 on the bottom, and the 3's will cancel, and we'll get 2 plus 2i divided by the quantity 1 plus I. You could do that now, or you could do that at the end. It doesn't matter. Okay? And then as I'm looking at this here, notice that you can also split this up into two fractions, and this will become 2, and this will become 2, so you get 2 plus 2i, and then you're done. So you don't even need at this point, you don't even need to multiply by the conjugate, because I noticed that the top and the bottom are multiples, right? The top is a multiple of the bottom. So we can divide this, which in other words, the top is divisible by the bottom. Okay, so you can actually divide this, and if you factor this out, you'll get the 2. No, actually, no, it won't. No, it won't. I'm sorry. No, nope, nope. So this, you can't divide this. I'm making a common error here. You can't divide across the plus sign here. So no, the best you can do is if you want to factor out the 3 at the top, factor out the 3 at the bottom, cancel those, and then you'll have what? You'll have 2 plus 2i divided by the quantity 1 plus 1i, and then yes, you'll have to do the conjugate. So there's no way around that. So again, yep, sorry for that. So back to the my original statement. For a second there, I thought you could simplify this further, but you can't. So that's the end. Okay. So you could, again, simplify this by factoring and then doing the same thing that we did here. Okay, so that ends this section. So now, next time we're going to talk about section 1.5, and we're going to talk about solving quadratic equations. Now, please, 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 make sure you listen to this video over and over again, and please make sure you do the examples here on your own without looking at the solutions. See if you can do them without looking. Do some of the examples at the back of the book, in the textbook, for this section. And then again, ask questions in class. Email me. Go to the tutoring center. Okay, I can't say that enough. But next time, we'll start on 1.5. But until then, good luck on all your homework. Practice, 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 and I'll talk to you later.